So welcome students. In this question you're given three statements. You're asked to see which of these are right. So first statement is mode can be calculated from histogram. So the first statement is true, right? Because you know the method by which mode can be calculated from histogram. You have this method in 10th class, that is, you have the histogram. So if you have the histogram of the data, something like this. So if this is the histogram. So the class having the maximum frequency is called model class, right? And after you find this model class, find the mode, what you do is you connect this vertex with this point by a straight line and the frequency of the next class with this point. And the intersection point will correspond to the mode of the data. So this is the process by which you calculate mode from the histogram. So the first statement, mode can be calculated from histogram, is right. Next, if you take the second statement, median is not independent of change of scale. So what is the meaning of change of scale? So change of scale means effectively each reading is being multiplied by some number. That is, if I take, so if you assume that you have the graph, if you take some data and plot the median. If you take some data and plot the median. That is, the data is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So let us say that this is the data that you have. So 0, 10, 20, 30, 40 and 50. And let us assume that you calculate the median of this. So you get some median for this data. Now if you change the scale of this graph, that is, instead of 1 to 10, I'll take this as 100 units, 200 units, 300, 400, 500. Now will the histogram remain same? The histogram will shrink, right? The histogram will shrink because all the data is in between 0 to 50. Now the scale of the graph has increased from 0 to 10 to 0 to 100. That means this histogram will shrink and come within this small region, because now this is 0 to 100, so 50 will be here. So now this histogram will shrink. Hence the median, which initially was here, now goes here. Hence the median is changing with respect to the change in scale of the graph. Median is not remaining at the same value. So the median is not independent of change of scale is true. And variance is independent of change of origin and change of scale. So change of scale means you are multiplying the data with some particular constant. And change of origin means that you are uniformly adding or subtracting a number from the given readings. That is, if you take this and if you change the origin to this point, so the median does the median change? If I change the origin, initially the median is something like 25 or so. Now if I observe from this origin, the median is something like, it increases, right? If I see from this origin, the median is increasing. But variance does not depend on change of origin, but it depends on scale. Because if you change the scale, we know that the variance changes. So if you add or subtract some value from all the values, the mean and standard deviation, if you observe these two parameters, the mean increases or decreases by k, but sigma does not change with change of origin. With change of origin, sigma does not change, but mu changes. If you multiply the readings with some number, that is, if you change the scale of the readings, the mean also changes, the standard deviation also changes. So the variance is independent of change of origin and scale is wrong. Variance is independent of change of origin, but variance depends on scale. So this statement is false. first two statements are true. Thank you.